We're starting a new unit today on the chemistry of life. This is unit 2, and it's chapter 2 in your textbook. So if this is the first screencast that you're listening to, you can take notes along with it, and you can pause the video when you need to copy some information into your notes. And just going back, these are the essential questions, the lessons for this unit, and we're going to start here with lesson 2.1. How is water essential to life? But before talking about water, we need to have some basic understanding of chemistry for biology class. So one of the ways to remember what elements are important in biology that make up 99% of all living things is this saying, CHNOPS. So carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. So CHNOPS. And you're also going to hear about trace elements. So occasionally you'll hear about things like iron, iodine, fluoride, copper, zinc, and calcium. So I have calcium up here. That these trace elements make up the other 1% of most living organisms. So there was a homework assignment where you took a look at a bush and a carrot and a rabbit and some different organisms, and you'll find that essentially all of these organisms contain these ingredients, but then in different amounts. We're also going to just talk about some prefixes that will be very helpful to memorize. Mono means one, di means two, and poly means many. So again, keep those in mind. And then last but not least, to keep in mind, while these are elements have subatomic particles called protons, electrons, and neutrons. Protons have a positive charge, electrons have a negative charge, and neutrons are neutral. We pay a lot of attention to the electrons in this course. When it comes to chemical bonds, it's all about the electrons. So there's two main types we're going to talk about: ionic bonds, which is giving or accepting of electrons. Ionic bonding is created from ions, which are charged particles. So if you take a look here, you have sodium ion and a chlorine ion combined to make sodium chloride, or otherwise known as table salt. So when you see this plus, that means that it's a positive ion. This is a negative ion. Covalent bonds simply are sharing electrons. So if there's a single covalent bond, that means that it shares a single pair of electrons. Double covalent bonds, triple covalent bonds. So go ahead and draw arrows to the pictures that represent the single covalent bonds, the double, and the triple. And you can see I just added my arrows there. And again, the lines represent how many pairs of electrons are shared. Hydrogen bonds, when a hydrogen atom connects to another atom. So just a review of chemical equations, if you will be using two chemical equations in here, photosynthesis and cell respiration. When you see two reactants being joined together, we would talk about it something being built. If you see something being broken down, or one being broken down into two separate, that's breaking down. The products are always on the right side of the arrow. So I always think of P in products, thinks of points. That's what the arrow points to. The reactants are on this left side of the arrow. Whether they're things being joined or whether it's something being broken apart, they're still called reactants. Other useful chemistry terminology is polar, which means an unequal sharing of electrons. A classic example of a polar molecule is water. And nonpolar is if there's equal sharing of electrons. We'll take a look at that in the next slide. Hydrophobic is, if we look at the prefix hydro, which means water, phobic means fear, philic means love. Hydrophobic means it's a non-polar. It does not want to bond with water. Hydrophilic are molecules that are polar and will bond with water. Monomer refers to one molecule. Think of it like a brick or a building block. Mono means one. We mentioned that in the previous slide. Whereas a macromolecule, macro meaning big or large, it's the opposite of micro, which means small. A macromolecule is a large molecule made up of many monomers. And I asked kids today, you know what AKA is like also known as? A macromolecule is sometimes called a polymer. So if you want to look at a school and you think of it as like a big macromolecule, you can think of, well, what makes that school? And you can think of all of the bricks that went into it. So that's a good analogy to remember the two terms. There are two processes that are used to build or break down. So synthesis or polymerization is the to build phase, where you take a bunch of monomers and you put them together to form a polymer. So again, you could use either name, synthesis, polymerization. Those are the scientific names that mean to build. Decomposition is the opposite. It's to break down. So pause the video and take a second to draw what a picture would look like using these words, monomers and polymers, to draw decomposition. And here's a student's drawing from today's class of what it would look like. Finally, the last kind of chemistry review is the idea of a solution. All the components of a solution are evenly distributed throughout the solution. So a solute is the substance that is dissolved, and the solvent is the substance doing the dissolving. So draw an arrow to the picture that represents the solute, what's getting dissolved, and draw an arrow to the picture that represents the solvent, what's doing the dissolving. And your arrow should look like this. So as we start to talk about water, we need to mention the term inorganic compounds. Inorganic compounds can be a very complex subject. We're specifically just talking about water, acids, and bases, basically chemical compounds that don't contain carbon. So we'll start with water, and the next lesson will be on acids and bases. The symbol for water is H2O. Often acids are represented with the hydrogen ion, and bases are represented with the hydroxide ion. The pH scale you're familiar with is a concentration of the hydrogen ions present, and that's what gives something its name, acidic or basic. So let's take a look at water. And I encourage you to make sure you read section 2.2 to kind of follow up with our lecture in class. Water, represented by H2O, consists of 2 hydrogens and 1 oxygen. Just as a little reminder, if you have a large 2 in front of the H2O, that means you have 2 water molecules, or a total of 4 hydrogens and 2 oxygens. So water is a polar molecule because it has a slightly positive charge on one end and a slightly negative charge on the other end. So let's tie in what we learned earlier about those electrons and forming bonds. So I circled them in pink. I circled the electrons. This right here represents oxygen. And if you're wondering what these are in the center of the nucleus of the atom, that's the protons and neutrons. There are 2 electrons in the first orbital, but then there are 8 electrons total. So there's 6 electrons, the ones with the check marks, 1, 2, 3, 4, 5, and 6. There's 6 other electrons that belong to the oxygen for a total of 8 electrons. So this oxygen is attracted to the 1 electron that this hydrogen has, because now it has a full octet shell, and the hydrogen has the 2 electrons that make it a complete shell. So this is a form of a covalent hydrogen bonds, covalent bonds, whereas the hydrogen and the oxygen are sharing these electrons. However, it's an unequal sharing. The oxygen tends to be more negative and pulls on the electrons more than the hydrogen, which tends to have a more positive end. Some facts about water, and tomorrow we're going to get into more details about water. Again, if you need to rewatch the video or pause it at times to write down the notes, please do that.